Hello and welcome to this tutorial on C# inheritance in Unity. We are going to animate the snakes here and implement a controller to the base class that holds the common functionality of enemy controller and platformer controller, so we can move the redundant code that is duplicate in those two classes into one common base class. Let's start with a small recap on C# inheritance, or inheritance actually in all object-oriented languages that support it, with the all-popular animal example. Here we have dogs and cats and a base class called animal. The idea of inheritance is always that you find common ground between different classes and abstract those into a base class that can hold these properties, so you don't have to repeat the different portions of code in multiple different classes. For example, a dog and a cat both would have a name, so the name property would be abstracted into the animal superclass. But a dog can bark, a cat can meow, so those are different methods, which means that they won't be implemented in animal but in their respective subclasses, dog and cat. And you can go down this inheritance tree as far as you want and distinguish as far as you need to implement your different subclasses. If we look at the platformer controller that we programmed in the platformer controller tutorial video, or actually any Unity script for that matter, we can see that we are already using inheritance actually. In C#, the syntax to make one class inherit from another class is this colon here. So MonoBehavior is the base class for Platformer Controller 2D. And MonoBehavior is what makes the Platformer Controller 2D a Unity script and enables it, for example, to be attached as a component to a game object. So all of our scripts are MonoBehaviors. Things like the getComponent method, for example, or transform, the field. Those are all things which are defined in MonoBehavior or one of MonoBehavior's base classes. So if we go to getComponent and peek the definition here, we can see that it is defined in the component class. Component inherits from object, and MonoBehavior in some point in the hierarchy will inherit from component. So there is quite the chain of inheritance already going on in Unity, and we're simply going to inject one more element in there to abstract our controller classes and make the code a bit more reusable. If we compare the platformer controller and the enemy controller that we programmed in another tutorial, we can see that they share quite a bit of functionality. For example, they both have the functionality to be grounded. So let's go ahead and move this into a base class. First, we need to make that base class. So I will create a new script and call that controller2D. And then make sure that we move all of the stuff that we have in common in enemy and platformer controller into controller2D. So first of all, that would be the speed, the variable grounded, the layers, the race here, but not, for example, the ledge test. That's something that is custom for controller2D. So we can move all of these variables here into the superclass, and then also the rigid body 2D. So now, of course, enemy controller will complain, hey, where are my fields? So it can't find speed or rigid body 2D on that. So we have to make sure that it will inherit from controller 2D instead of MonoBehavior. Then we move the methods that we can move. For example, update grounding, or actually that would be the only method in this case that we can move because platformer controller and enemy controller both have them. So let's move update grounding here. And now address some of the errors that we created by doing that. Here, rigid body 2D is now underlined red. It causes an error that it is inaccessible due to its protection level. So let's have a look at the variable in the base class. You can see that it is defined as private. grounded would be public, so we don't have a problem accessing that. There, everything is fine. But rigidBody2D would be private, so we cannot access that. But we don't want it to be exposed in the inspector or be messed around with by classes from the outside, so we can't make it public. But there is another access modifier that is called protected, which makes this field available for ourselves and all classes that inherit from us. So now enemy controller can access rigidBody2D. Update grounding is also underlined and is inaccessible. If we look at update grounding, we can see that it actually does not define an access modifier. So it will have the default one that is internal. Everything in C# that you don't specify with a different access modifier is internal. That means it is accessible to its own file, essentially. So we want it to be accessed by a different file, so that does not work for us, but we should simply make it protected. Now that we have changed that, you can see that everything in enemy controller now is error-free. So let's do the same thing for the platformer controller. Here, first change this to inherit from controller to D. And then we can see that some of these are actually underlined green, and it's a warning that says it hides the inherited member, right? Because of course we redefine speed here that we have already defined in controller to D. So we get rid of all the stuff that is underlined in green. And there we go. And also the update grounding method here. We don't need that again. And the last thing we have to fix is the start method. Here, the start method only assigns our rigid body, which is actually defined in the base class. So the base class should also do the assignment. And we don't need a start method in enemy controller 2D either. But each enemy controller and platformer controller define an update function, so we should not have this update function here in controller 2D. If we then look at the inspector, for example, of our enemy controller, you can see that it doesn't change at all. So it still looks exactly the same like it did before we made those changes. If you look at the respective script, the enemy controller only defines these three fields here, and only the two ledge test left and right would be exposed to the inspector. However, we can see also all of the fields exposed by the base class. So inheritance is fully supported by the Unity inspector. Now that we have the basic inheritance set up, we can go ahead and animate our snakes. If I take a snake and put the animator 2D on it, now look at this script. You can see that it wants a platformer controller because our animators need to know whether we are grounded or not. They have the getAnimationState function in which we test whether or not our controller is grounded. But the platformer controller, of course, is not attached to enemy. Now we have the enemy controller instead, which also has the grounded inherited from controller 2D. So if we change in animator 2D platformer controller to controller 2D, we actually already fixed everything. So now the controller would simply be of the base type, and the base type has our field grounded that we can then test for, and we can go ahead and animate the snake. Or almost. Observe now how this line does not throw an error. We have a field controller of type controller 2D, and we get component of a platformer controller 2D still. This will not throw an error because a controller can hold an instance of type platformer controller, since the platformer controller, right, is a controller. But what we do want is just any kind of controller 2D that is attached, be it an enemy controller or a platformer controller. So this, of course, also has to be a get component grab of the base class. And that will then return any kind of instance of controller2D that would be attached. Good. I've then skipped ahead a bit and already set up the animator2D on my snake enemy, put on some FPS, and I put in the different animations. And now if I go ahead and click play, you can see how the snakes happily wiggle away and they change direction and work just perfectly fine. So to sum up again, what we did is to move the functionality that the enemy and the platformer controller have in common into the base class, the new base class that we made called controller2D. And this has now all of the shared properties that enemy controller and platformer controller both need. It also has the update grounding method, which then enemy and platformer controller would call in their update methods to update grounding. In this way, we can save a lot of code that both of those classes have in common and simply move that into a base class. We also learned that MonoBehavior is the base class for all Unity components, and every Unity script would inherit from that, and that all of the functions and properties like transform or getComponent come from this MonoBehavior class or its respective base classes.